Okay, welcome. In this video, I'm going to talk about get data insight through database part 2, and in this video, I'll talk about exploring relationship between income and life expectancy, continent-wise, facet function we shall use. And what is facet function? It is basically splitting a particular visualization data with respect to some other variable. I shall discuss today 5 number summary statistics as well. It's very useful graph for data having outliers for data which is not symmetric, and box plot is really a useful summary statistics instead of summarizing your social sciences economics data through normal distribution through mean and standard deviation. It's better to explore this data through these 5 number summary statistics: mean, max, median, that is quartile 2, Q1, quartile 1 and Q3, and it also highlights if there is any outlier. We can use ggplotly for interactive plot and line chart. I may discuss in the next video. So let's go to R, and we have discussed these things, so I'll move quickly. Library dplyr, library ggplot2, library gapminder. This is what we have been discussing in our previous videos. I'm going to generate data for 2007 year double equal 2007 gapminder 2007 data is generated, and I am using here ggplot. Data is equal to gapminder mapping. We are presenting GDP per capita on horizontal axis, life expectancy on vertical axis, color on color is another variable, and we are also using size of population. So we have this plot, and you can zoom it, see what's going on. In general, there is a non-linear relationship, but there is a big difference between developed countries and developing countries, though there is convergence going on as per Hans Rosling. You can listen his videos. So I'm going to store this data in object, but I'm not using here size variable. So we have stored this data in P, and we have labeled P plus anything in ggplot is plus, add something. You will have another you will have an added feature in that variable. So with P, if I type here P, it's not going to list my titles, but when I add P, and now if I type P1, because we have stored here variable data in this plot in P1, so now you have this title as well as you have caption, and you have horizontal axis, vertical axis. But what I'm going to use here is facet wrap. That is a function used to split your data visualization with respect to another variable. Here I am going to split this data as we have here colors. Now we'll split this data with respect to continents, and now you have this nice graph with respect to continents. This is your Africa, this is America, Asia, Europe, Oceania, and now you can see comparison within a continent. Within a continent, Asia pattern is more or less similar as the overall pattern of all the countries, but Europe very much close to each other, Africa huge differences, and America there is a lot of concentration here, and US and Canada are on GDP they are far better, but on life expectancy they are not that there is not much difference. So let's go and explore gapminder further. I'm going to use data for 1952, and I'm going to compare it with respect to 2007. Now you see I have generated 1952 data, and I have stored it in P2, and you know your P2 is this one. Look at this graph. This is very interesting finding. You have this value here which is very large, 90,000 plus GDP, or rather 100,000 plus GDP per capita in 1952. This distorts the whole picture. This distorts the whole graph. That's why you always need to take care of outliers. Now, what is this country? If you explore it, if I try to find out what is this country, so you will see gapminder, and if I filter it with respect to filter equal to GDP per capita greater than 50,000, let's say, because we have only one value, 50,000. So you see this is Kuwait. It has very high GDP per capita. So in 1952 Kuwait GDP is this one. So we have to basically know filter our data. So we have, at the moment I am ignoring outlier, but we should not ignore the outliers in our analysis, but just for comparison purposes I am ignoring outlier. Here GDP per capita greater than 50,000, we see Kuwait. In 1952 I am using another package which is called library grade extra. You can install this package, grade extra. Grade extra, now we can arrange this data, and now you can see a comparison between these two graphs, but due to this outlier. And secondly, you see, don't confuse the things here. Your vertical axis are from 0 to 70, 80. Here you have this one, this is on different scale, so you should not confuse your comparison here. Many a times people confuse, oh, these points are higher than this one. This is not the case. You can limit these graphs. For example, I can say P2 plus y limit between 0 and 90. 0, 90. Now if I plot this, now you will have same axis, that is the same axis as in that graph. So you should be careful about these things. Now I am going to basically short data, filter data for less than 50,000, and going to compare this data P3, same variables going on here. You can see the geom, continent, and everything. And now we are going to plot these three variables here. This function can only work if you use grid extra library. So you see, now in this case, if we ignore this one, so this one and this one, still you have vertical and horizontal axis different vertical values. So you should use same values. Let's go further. I'm going to explore Asia. For 1952 GDP per capita 30,000, so it's not affected by any outlier. And Asia 2007, okay, we just Asia 2007, Asia 1952, plot number 1952, plot is 2007. I have added here y limit so that we have similar comparison. And now when I plot 1952 of Asia versus 2007 of Asia, so you see we are far better here in 2007 than in 1952. So those who think in Pakistan, India, that we have no better lives, that's not the case. We have shorter lives, that's not the case. Life expectancy at birth in 1952 for most of the countries was less than 50, very few countries more than 60, but in this case many countries in 2007 have life expectancy, expected life at birth, that is more than 60. So life expectancy has increased, GDP per capita has increased over time for Asia. But what is this this low country 40? That is Afghanistan. If you explore it further, so that's why we put limits here. I'm not going to make it a very long one. Final thing, box plot. For box plot, we use this one. Okay, ggplot, gapminder, data as it is, X is here now a categorical variable which is continent wise life expectancy, and we can fill it, we can leave it as a blank with respect to continents. And now instead of using geom point, I am using geom box. So geom box I'm using here, and we can use it P11. Okay, P11 geom box. Okay, fine, it is stored in P11. Now we press and you see a graph here. You have an outlier in Asia, that is Afghanistan. You have an outlier in America here, that is spotted here. These are your median lives, and median life in Europe, in America, in Oceania is far higher than Africa. Asia has very, you see this 25% between Q1 and Q2, there is a huge dispersion. Anyhow, let's move further, and finally I'll go with interactive plot, and that's it for today. We'll use line chart in the next video. Library plotly, ggplot Lee P1. Let's say I say P2 or P1, and you see now this is your interactive plot. If I zoom it, we have this interactive plot, and you can even label these with respect to countries, and when you browse here you have GDP per capita as well as life expectancy per year. So you see we get deep insight by having visualization of data. We are getting that these countries have high GDP but low expectancy, less than 50. These countries have similar GDP as compared to this one, you see 10,000, but have high life expectancy. That's what one needs to think, that how it's possible, why these countries are not making progress. You see this this one green dot here from Asia, and that's Afghanistan I have already mentioned. So please explore this data at your own and draw your get your insight, understand this data first. We'll discuss line chart in our next video. We have discussed box plot, facer trap, and interactive plots here. Thank you for watching. Take care. All the best.